Welcome back. I'm Travis with Linux Academy. In this lesson, we're going to talk about container logging. There's two things we're going to be talking about in this lesson, which is how to go and retrieve our logs for a container, as well as how to go and send our application log data to our container logs. Now, the first thing we're going to do is we're going to go and stand up a new container. So we're going to execute a Docker container run. We're going to be using the name flag to call our container weather-app. We'll also be using the D flag to make sure that our container runs as a background process. We're also using the P flag to go and publish port 80 on the host and have it mapped over to port 3000 on the container. And finally, we're going to be using the image of Linux Academy content /weather-app. Okay, let's go and deploy out our container. Now, the application we're working with is written in Node.js, but the concepts will apply to other languages. Now that the container is done deploying, let's go and list it so we can get the container ID. There's two commands we'll be working with to go and retrieve log data. The first one is docker container logs. And we'll be using this command anytime we want to go and get log details on a container that is not running as a service. Now, if you don't know what a service is, that's fine. We haven't talked about them yet. We'll be talking more about services when we get into Docker Swarm. Now, to retrieve logs for a service, you will run a docker service logs and then the name of the service or its ID. But for now, let's go and take a look at the logs for our weather app. We're going to be executing docker container logs followed by the name of our container or the ID. Right now, we're not seeing a whole lot. We just see that it's listening on port 3000. Come over to Cloud Playground, and we're going to go and get the public IP. Open up another tab, and then go and paste the IP in. So here we are. This is the weather app. This app is designed to go and get the temperature for a city. Enter Dallas, and then click Get Weather. Now, as you can see, it is 60 degrees in Dallas. Each time I make a request, the name of the city will be sent over to the container logs. Now let's search for San Antonio. And also, if I submit an invalid request, it will also log an error. Now let's go and rerun the docker container logs command. There we go, that's better. Now we're getting more data coming back. As you can see, we have Dallas showing up right here. This is when I went and I submitted the request for Dallas. I also have one for San Antonio. And then here's our error log. If you haven't heard of the 12-factor app, no big deal. I will have a link in the description so you can go and check it out. Just to kind of give you a quick summarization, the 12-factor app are principles you should be adopting for any kind of cloud-native application. And this also includes applications that are going to be containerized. If you go and scroll all the way down, and let's go and click on number 11, which is logs. The TLDR is that logs are treated as event streams. A 12-factor app never concerns itself with routing or storage of its output stream. It should not attempt to write or manage log files. Instead, each running process writes its own event stream, unbuffered, to standard out. Now, the way I achieve this in the weather application is I'm using console log to send any kind of general logging data to standard out, as well as console.error for any kind of error messages. Now, if you're a Ruby or Python developer, don't worry, I didn't forget about you. For Ruby, you can use the logger class to send logs to standard out. And for Python, you can go and import the logging module. Now, there's one last way we can go and send data over to standard out and standard error. For example, with the Nginx image, access.log is being symlinked to dev standard out. And the same thing is being done for the error log. It's being symlinked to dev standard error. This allows you to take a pre-existing application that is writing logs to a log file and symlink it to standard out and standard error. The logging command is also a great way for us to be able to troubleshoot any kind of problems that we're having with a container. For example, let's say you go and execute docker container run and your container fails to start. Anytime there is an exit code of 1 means that there was some kind of problem and that the container stopped because of an error. And we can then go and troubleshoot the issue using docker container logs. Now let's go and create a scenario where our container fails to start. To achieve this, we're going to go and deploy out a Ghost blog container that talks to MySQL. But we're not going to go and deploy out MySQL. So that way we were able to go and generate this error and we can go and troubleshoot. Great, our container is now done deploying. Let's go and take a look and see if it's running. It looks like our Ghost blog did fail to start. In order to view it, we have to use the A flag. And our container did exit with a status code of 1, which means there was a failure. If we got an exit code of 0 instead, it means the command ran successfully and then exited successfully without any errors. Now let's go and take a look at the logs for our Ghost blog. So it looks like our container is spewing errors, and this is because there is no MySQL database for the Ghost blog to talk to. So anytime you have a container that is failing to start, Docker Container Logs is going to be your best friend. Now this does complete the Docker Basics section. To quickly recap, we've learned how to go and pull images from Docker Hub, how to go and deploy a containerized application. We then moved on to ports, where we talked about how to go and export ports, as well as how to publish them for a container, and then how to go and execute commands. The next section, we're going to be covering networking and storage. Go ahead and mark this lesson complete.